Back, start of a new week. Not sure, is this week 6 or 7 or something? Anyway, we're in the middle of things. So let's take a quick look. I passed back the exams today. You guys are actually doing wonderful. Again, individually, you may either be happy or sad or somewhere in between, but on the averages, we're doing great. Homework, 91.3% completed, which is awesome. So that's an average. Some did, the 105% is the highest you could get. So homework was well done. Quizzes, again, it's actually a little under. A few have not verified that they did the practice, which I count as a quiz. So if you haven't, you can still go in and take the little quiz, say that you did do it if you did it. But pretty much that was 100%. And again, hopefully, the more of it that you do or study, you'll do well. There was a few that actually didn't do much homework, but they must have studied that because they did well on the exam. And then the test average 77%, which is relatively good. It's almost at the B level, which we're happy if we see about a 70% average for tests. So we're doing well there. And the overall average grade is at 81%. So we're B's and A's mostly. Again, individually, you may be at different places. So we've had a long email string between the instructors about what to do, because some classes, like in 210, you may know there was like a resurrection final because the final was comprehensive, so they could replace the lowest grade. This class, it's not comprehensive, which is good in one way, that you don't have to remember this stuff for the final. But in the other way, we can't really replace this test because this material is not going to be on the final. But if you're willing to keep engaged and it's like going to really bring you down or something, we'll have a few things that we will do, that we can do. What I'm going to ask is, though, mainly you focus on getting through the content for test 2, so you do really strong on test 2. Because if I see a good grade there, we can say, okay, we can rectify, maybe we could do something here to help you out. But if we don't get a good grade on 2, it really won't matter what we do with 1 if we're not progressing. So here's the first thing. Over spring break, anyone who didn't finish all of the homework, whether it's one assignment or all of them, I will, for test 1, I will reopen it as long as you are making progress, good progress. You're halfway through the stuff for 2. I want to see that. I don't want to sacrifice test 2 to try to finish up stuff from test 1 that's only going to help you. I'll be honest, even if you did none of the homework and you do it all, it's only going to help your grade by 3%, right? Because the total, 5%. The total of the homework is 15% of your grade, I believe, if I get this class right. And so there's 3 tests, so 3 sets of homework. So it'll help your grade about 5%, which might be good. But if it sacrifices what you're going to do on test 2 because you don't get prepared, it's not a good trade-off. Okay, so as long as you're making good progress, if you have any exam or any homework that you need to finish up in section 1, as we get next week, I'll just put it open. Next week, you can start emailing, because that's what I'll be able to check. And you can say, I'm halfway through exam 2 stuff. Can you open up a few of these, extend them for me? Because I can do it on a person-by-person basis. So we'll do that. That will help some of you. Others, you're just fine anyway. And then there is not really there are some test correction things we can do during office hours, potentially. But again, what I'm going to do is I'm going to wait till after test 2. The nice thing is, since we don't have a comprehensive final, as we get towards the end, we're just studying for another block. So it's not as much study time required as in a class that does a comprehensive. So as we get to the end, we can say, hey, things are going well, but you scored a 20 over here. If we could get that up to maybe a 40, it'll make a big difference. Or if you score, whatever, we can take a look at how it's going, but we can say you're on track to do well. Let's come up with something, okay? And it will involve going back and basically doing another similar type home problem, probably during office hours or beforehand, or we'll work it out. There's also going to be some times that are going to open up. I realized when I looked at this, 5.3 and 3.6 are actually the same homework. So they're combined. What I'm going to do is I'm going to move Kramer's rule. I'm going to move everything up so that the Friday before spring break is going to be a work day. So if you're on track and everything and you want to start spring break a Friday early, actually Thursday maybe, depending upon your schedule, we'll make the Friday before spring break just an open work day. And so that's where we can start making things, talking, whatever, get things on track. And then we'll keep this part here the same. And I'm imagining down here I did something similar because I split some things that I said, oh, they're not really split. So we'll probably be able to pick up a couple Friday work days. Okay. So we good with that? So again, main thing is don't worry too much about the stuff from exam 1 for now. Get on track with exam 2 stuff, learning it, feeling good about it. And maybe as you go, let me go back here. So today we're going to do the matrices to solve systems of equations. That'll review a little bit of the end of 5.2. And remember, there's these exam review resources. There is the review exam in there. And now's probably, maybe after we get at least through this week, will be a good week to start maybe reviewing the first half of that to do well. Okay. And again, a number of you did awesome. I have handed back the exams. If you didn't get yours, I've got them here. So check in on your way out. I'm always open to discussing how I assign partial credit. I'll just be honest, sometimes it's a crapshoot. Should it be 5 points, or should it be 4 points, or should it be 6 points? Sometimes I'm going through so quick, I miss something. You could point out, well, see, I had that. Oh, that's what that meant. Okay. So yeah, another point or two. So those things, we can have those discussions. I'm happy to do that. I'm not perfect. I'm not infallible. I'm probably the opposite. So anyway, but I do my best and I want to be fair. So that's why we have those discussions. Okay. Any questions or concerns? Okay, today it's like one of my favorite lessons of all math, matrices. And let's see, we are recording. Yes, we are. Okay. Let's go into this. So what we're going to do now is we're going to use matrices to solve systems of equations. Systems of equations just mean we've been working with systems of equations, whether we call them that or not. So when you took the partial derivatives, you took two partial derivative of x, partial derivative of y, you set them equal to 0. They were simultaneously equal to 0. That was a system of equations. And we solved those to find out what x and y was. And then when we were doing the Lagrange multiplier thing, we had those two, plus we had that g of x function as another simultaneous equation. So we had 3 equations that all were connected, all simultaneously. We now could actually solve those with the method of matrices. And that's what we're going to talk about today. So this is solving, 2, 3, 4 equations. And what this is going to help us with is we are actually going to have the ability to solve for like 5 or 6 unknowns given enough equations. And typically, it can sometimes be different, but if you have 5 unknowns, you need at least 5 equations. You could have more, but at least 5 equations, simultaneous equations, and then you would be able to solve for them. If you have 6, you need 6. However, not all systems have solutions, so we're going to look at that. Some systems actually have an infinite solution because maybe 2 of the lines are sort of on top of each other. Again, we're in maybe 3 dimensions or 4 dimensions or 5 dimensions. So there is a possibility for infinite number of solutions, but what we do is we come up with equations for those. And I think we're only going to do that in the homework up through 3 dimensions. There is one in the homework, if I remember correctly, that is in 4 dimensions. So we have x, y, z, but they had to introduce a w because they needed one more variable. But again, we're going to be able to do it. And this is where you're really going to want to have a handheld graphing calculator that can do matrices. TI-84 is what I'll demonstrate today. But again, the Casio will do matrices. Numworks will do matrices that you can download. So we're going to use it heavily. Okay, we're going to use it heavily. Okay, so here's an example. We can turn an equation such as 2x minus y equals 3. We can turn that into a matrix. And the way we do that is we just focus on the coefficients in front of the variables. So that's a 2 and that's an invisible 1. And the constant term, whatever it's equal to. Could be equal to 0, whatever, but we get a third number over here. And so we just list that as a row matrix, in this case 2, -1, and 3. Okay, so that's how we're going to use a matrix. Now, this is not the only use for a matrix, but it's what we're going to focus on, and it's one that really is valuable for us. And if we have a matrix, we can also think of it as if we're told that it relates to an equation. They call this an augmented matrix, which we'll see the definition later on. Augmented because it includes basically the other side of the equal sign. So what we're seeing here, this column would be x, this would be y, there would be like an equal sign here, and this would be what it's equal to, a constant. But notice, and we could do this for multiple equations, so that's how we get more rows in our matrix. So this is just a look at one equation, one row, but we're going to do it for many of them. And in this sense, we're able to represent an equation without any variables. It's just a bunch of numbers, but we know what those numbers mean. Okay, the equation sign, equal sign, is gone, but it's sort of implied to be there at the end. And when we have these things, we can also take the matrix and we can turn it back into a equation. So we know that 2 times x, -1 times y, 3 by itself. So we're going to see we can go both ways, and we will go both ways for it. Okay, so that kind of ties into what we were doing at the very end of the lesson that we sort of rushed through when they were multiplying by xy or xyz. They were kind of getting us to this, that you can take an equation, make it into a matrix. You can take a matrix, make it back into an equation. Okay, so that's the basis of what we're doing. So this is for augment, and it's called an augmented matrix because it has the variable parts and it has the right-hand side of what it's equal to, so a constant. So let's take this equation. How would we turn that into an augmented matrix? Well, we have one row, right? And it's just take the numbers. There we are. We have an augmented matrix. So we just listed the numbers that are listed there. Okay. Yeah. So just a little practice, but that's all we're doing. Could we turn it back in? Yes, we could take the -4 times x plus 2y equals 0. How about this one? Let's see. Well, there's no x though. So what am I going to do here? Good. 0 for x. So there's really a 0x here. It's invisible, but that's what made it invisible. So 0, -3, and then 1/4. So they do pretty much stick with the convention. They'll start with their variables at x, y, and z. And then if they need a fourth one, they'll go to w, or actually back to w, right? W, x, y, z. But we'll start with x. So if there is no x variable, we know that there's a 0 in front. Okay. So that's sometimes the hardest part is recognizing when there's something missing, right? Or sometimes when there's no number there, that there's a 1, right? When it's just x, it's really 1x. So those are the two types of things I sometimes will make a mistake. Or forgetting to put the negative, right? If it's a -y, that's a -1 that goes there. And so if we forget those, oftentimes we don't get the right answers. I did that a few times myself. I was going through, oh, I just missed a negative. That's why my answers aren't matching what the textbook's coming up with. So far, are we good? Not too bad. And again, the good thing is the math we do is we're either going to multiply or divide or add or subtract. So that's the math. It's not no calculus here. Just add, be able to add, subtract, multiply, divide. We'll be fine. Problem is, it's all a little complicated, right? But again, we're going to use our calculators to do a lot of this checking for us when it gets, as it gets more and more complex. So the first number is always the coefficient x, the second is the y, and if they're missing, then we got a 0. Okay? But we call that row a coefficient row. Okay? Coefficients are just the numbers in front of the variable. Okay? Like the coefficient of drag is a number, how much drag you have on your airplane or car or whatever the drag is, friction. So again, what do we have here? We've got 2, we've got -1. Again, remember, there's a missing invisible 1. And we've got a 3. Oh, and we got more. So we've got a second row now. We've got a -1, a 2, and a -4. So now it's starting to look more like a matrix, right? And the other one it was a row matrix, but now we're getting some dimension, a 2 by 3 matrix, right? And that's what we get. Let's see if I got it all right. Not too bad. Again, just copy things down, but put them in the right place. And the thing is, we're going to be able to put this into our calculator. It's going to be able to solve for these variables. Now, we're also going to look at the techniques we use, because we have done, probably you've done methods of simultaneous equations, like solve them for y or solve them for x, substitute into the other one. So those all work. And they work probably better for these if we only have 2 variables, but they don't work real well if we have 4 or 5 variables. So these methods we're going to work on are a little bit overkill for just 2 variables, but the techniques you'll see work for the bigger ones. So that's where we're going to go. Okay, and again, they emphasize this is an augmented matrix. Again, we're not going to ask you to define that word, but just when you see that word, you kind of know what it means. Augmented just means it's got your variables, it's got it equal to some number. So that's it will not be a square matrix, right? Because I guess it could be if there was 1 variable and 2 equations, I guess you could have a square one, but most of them will not be square because 3 unknowns, 3 equations, you've got 3 rows, but you're going to have 4 columns, right? Because you've got that other side of the equal sign. Got all your variables plus the constant. Okay. So let's go backwards. Okay, we saw this matrix a little earlier. How could we turn it into an equation? Reading this, remember x is the first variable, then there's y, and then there's our constant, and it's going to be this, and this will be either a plus or a minus, right? So this would be 2x minus 1y equals 3. And this would be minus 1x plus 2y equals -4. Okay, so just be able to kind of go back and forth, even mentally, just so we start to see these augmented matrices are equations. They're series of equations. How about this one? What does this first row become? 1x, which is just x. How about y? 0y, so that would be 0, 2/3. How about this one? 0x, which is 0, plus 1y, which is just y. Would you believe me if I told you that if I plug these numbers into x and y up here, that we'll get 3? And that if I plug them into this equation, we'll get -4. That these are actually the solutions to that matrix, that equation. And just to show you, so let's do it down here. We've got 2 times 2/3 minus y, which is negative 5/3, right? A negative negative is going to make a positive. Does that equal 3? Well, 2 times 2/3 is going to give us 4/3. A negative and negative give us a positive 5/3. Does that equal 3? 4 plus 5 is 9/3. Does that equal 3? Well, yes, 9 divided by 3 is 3. So it kind of checks. That was a solution. Okay? And I made it this way because I want you to see is when we take a matrix like this and we solve it, we're going to get a matrix like this. Does anyone remember what this one along the diagonals with the zeros, what that matrix is called? Identity matrix. We kind of went over it a little bit, that if you take a matrix times the identity matrix, which is ones along the diagonal, zeros everywhere else, you get the same thing back. So once we've gotten it to the identity matrix, notice this is really x equals this is y equals that. If we had more variables, we'd have a 1 here. This would be z equals this. So this is our solution matrix. Cool part is your graphing calculator will do this. My graphing calculator did this. That's how I got the solution. So we are now in a place where our calculators don't do algebra. If I put those variables in there, it couldn't handle it. If I try to give it the equations, it can't handle it. But if I give it the matrix, it's got a little tool. You push a few buttons, you get your answer. Okay. So I want you to see what we're working towards. So what we're going to do now is, before we talk too much about how to use the calculator to do this, we're going to talk about how to manually, we would go about changing these numbers into these numbers. And the cool part is, remember, these are equations, right? What can we do to an equation? If we have an equation, it means both sides are equal. What are some things we can do to, as long as we do it to both sides? We can add the same number to both sides, right? And the equation's still equal. We can multiply both sides of an equation by a number, as long as it's the same number, 5 times 5, We can divide both sides of an equation by the same number. We can do all that. So we're going to see that's what we're going to do. And basically the goal is turn this 2 into a 1, turn this 2 into a 1, and turn these negative 1s into zeros by just those simple processes. And there's basically 3 things we can do, so we'll go through there. So here's an example. We've got an augmented matrix. And again, we could think about, we've got a system of equations. We want to get the augmented matrix. So again, sometimes in the homework, that's what they'll give you is these. They want you to solve it, and you're going to say, okay, that's the matrix 1, 1, 3, 1, negative 1, 1. And then you're going to plug it in your calculator, hit the right button, and it will solve it for you. And also we'll show you some by hand methods as well. But we'll do that. So that's our augmented matrix. Oops. I should have almost wrote it right on top. That was pretty good. I'll take that out. So there's our augmented matrix. And then what we're going to look at is what can we do to this matrix? What are the things that we can do? So we've got equation 1 is row 1, right? Equation 2 is row 2. So we've got some shorthands. They're going to list E1 will mean the first equation. And then they're going to refer to, when they're talking about the matrix, row 1, R1. Okay, because we're going to do these side by sides, because so far we're probably comfortable working with equations. We're going to see how we do the same thing, how it looks when we do it with the matrix. Okay, so what they're going to do, and again, sometimes I cut out some of their slides, so if you look at the full presentation, you'll see them working through some things. They do it a little differently than I would. How I was taught, they talk about a pivot point and this kind of stuff. I thought, that's too much stuff. You don't really need to know all that stuff. So if you look at it, you'll be there. So anyway, they're talking about, they've got equation 1, and they're going to multiply both sides of the equation by negative 2. So you can see 2 becomes negative 4, negative y becomes positive 2, and 3 becomes negative 6. What that looks like if we did it with a row is really the same thing. Notice just the x and y and the equal sign are gone. We take negative 2 times 2, we got negative 4. Negative 2 times 1, we got positive 2. Negative 2 times 3, we got negative 6. Okay, so what we've done is we've effectively changed that first row of our matrix, but we haven't changed the equation, have we? Right? Because and that's what you have to kind of get used to. We just multiplied both sides of the equation, so both sides got bigger or got multiplied by -2. So it's really the same equation, or the equalities will still work. Okay, multiplying both sides of an equation by the number of a corresponds to multiplying the coefficient rho by a. So these are the same processes. Okay. You can add two equations together, which we've done with similar or systems of equations. Because remember, if something's equal, both sides are really the same number. And so when we have this equation equals 3, we're saying that 2x minus 1 is also 3. So as long as we add the same thing to both sides, it's doable. So they look at that. Yeah, we could add two equations together. And notice we end up with y equals -1. So we end up with sort of a solution there, right? By adding two equations together. 2x this and this. And what it would look like is what they're doing is they're taking row 1 and row 2, they're adding them together. And then typically what we will do is we can do that, and then we could put that in for one of the rows. So this is an operation you could do. So we can multiply a row by the same number. We can take two different rows and add them together and replace one of the rows. Because what you're doing, remember, when you're adding a row to a row, you're adding the same thing to an equation, to both sides. That's what we're doing. It's just a little bit more abstract, but it's doable, it's legal, and gets us to where we want to go. So those are the two things that we need to do. There's a third thing that's even easier. We can move the rows around. So the order of the rows of first row, second row, third row, that's sort of arbitrary, right? Because if we have equations, it doesn't matter which order we take them in, right? We've dealt with those constraints. We can do with them in any order we want. We can so equations are just, there's no particular order, so we can move the rows around. So those are the three things we can do, and we're going to highlight it here. So we could take row 1 and we could replace it by a times row 1, or I, plus b times row j. So we can, again, multiply, change it, and replace it, because it's really the same thing. We can add another equation to it and replace it. And that's kind of how we modify the equations to become those things. So those are called row operations. And there's 3 elementary row operations. So let me highlight those. Oh, I did it sort of backwards. These were supposed to come in later. So type 1, we multiply by a constant. Multiply the whole row by a constant. That's multiplying both sides of an equation. One thing we can do. Seems easy. Second is we can do that, and on top of that, we can add any 2 rows together. Okay, because that's adding the same thing to each row. And then we replace one of the rows with that new result. So that's always what we're doing. And then the third thing we can do is we can just go ahead and change the order of the rows. The one I'm going to show you is I'm going to do that first because it's got a 1 in the place I want it. So I'm just going to move it up there because I think that's the easiest way to do it. So we can do any of these 3 things, and these are the only 3 things we need to do to be able to solve a matrix. We good so far? We can multiply, we can add, and we can change the order. That's all we have to do, and we will be able to solve these. We will be able to get every matrix that is solvable into 111s on the diagonals, zeros everywhere else, and we'll get our solution. If it's not solvable, we're going to see what happens. Okay, a couple examples. So let's see this one. And I just got these. So type 1 is we could take row 2 times 3. Okay, so 0 times 3 is 0. 4 times 3 is 12. 2 times 3 is 6. And we basically, this is sort of how we do it, is if you're going to do this, I didn't do this, and that's where I got a lot of problems, is when I made a mistake, I forgot what I did, right? but I'd start with a matrix and then I'd write what the new one was. Okay. Sometimes you might on your scratch work want to, do some of this stuff, but especially if we're going to multiply and then add it or something. But here's our new matrix, and this is an equivalent matrix, so we can work from there. Replace R2 by 3 times R2. Type 2 thing, again, they're going to give us a, well, it's the same matrix. You could take 4 times row 1, subtract 3 times R2, and notice so there's multiple things being happening here, and then they've replaced it here, and they've got the 4, 0, negative 22. Okay, but that was a lot that went on. They took 4 times row 1, so row 1 became 4, 12, negative 16, and they subtracted 3 times row 2, which we have up here, so that would be minus 0, minus 12, minus 6. So that gives us 4. 12 minus 12 is 0. 16 minus 6 is negative 22. And that's how they got that. So you'll see if you do these by hand, you may need to kind of go to the side and do a little scratch work, and then you put it back in. But you want to kind of do this. You have some messy area where you can just kind of do things, and you've got a nice organized area where you keep track of your matrices and how they're changing. Okay. And then a type 3, this is a new matrix they gave us, but you could switch row 1 and row 2. So they've taken row 1 and they moved it down to row 2. You could do that. Again, why would you do that? I don't know. Again, the goal is to solve an equation. To solve one is we want 1s along the diagonals, 0s everywhere else. So we're going to work on one that's a little simpler, and then I'm also going to show you how to do that with the graphing calculator in maybe 10 minutes or less. Okay. So it's a little wordy, but the reason I kind of left this is the reason we can do this is because we can undo it. So we can do it and then we can invert it. So if I multiply by 3, I could then divide by 3 and get back to where I started. So in mathematics, that kind of says if I can get here and I can get right back to where I started with an inversion, a reverse operation, then it's all good. And that's basically all this is saying. It is, yeah, if I do this, if I multiply by 4, subtract 3 times that, I could divide by 4, and this should be divided by 3, so I think they got an error here, and I add instead of subtract, right? Because the opposite of multiplying by 3 here would be to divide by 3. I think that's a mess. Yeah, it should be. And then switching rows, if you switch them, you can switch them back. Okay, so all of these things, it's just saying mathematically, it's kind of like a little proof. Since we can get back to where we started, they're all good things, all things that are legal to do. Make sense? If not, that's okay. We'll go through and we'll see how the answers are, because a lot of this is just getting to work with it. So let's try one. So we're going to be given a system of equations, something like this. What's our first thing to do? We need to turn it into a matrix with just the coefficients. So I have negative 2/3. I have 1/2, and I have negative 3. So notice there is no plus or minus, or there's no operation signs. I have, if there's a negative, I have a negative there. There are no variables. There are no letters, but they're sort of just hidden in there. And the bottom one is x over 4, so that is 1/4, negative 1, and 11/4. So that's what we're going to work with. Get rid of all the messy stuff. But everything we're doing, we can come back and we'll have our solution. One of the cool things to do when working with matrices, if you're going to work with them by hand, now, if I was working with this with my calculator, I would just enter this in, and we'll do that in a moment. But I want to show you I don't like working with fractions. How about you? No, we can kill the fractions. We can multiply this top row by 6, right, the common denominator, and we'll get rid of the fractions. We can multiply this bottom row by 4 and get rid of the fractions. So let's do that first. So I'm going to take, I'll put my notation here. I'm going to take 6 times row 1. I could multiply by anything. I could multiply by 12 if I want, but 6 will get rid of these fractions, right? So let's do that. 2/3, and again, if I need some scratch root, right? Negative 2/3 times 6. 3 goes into 6 2 times. 2 times 2 is going to be negative 4. So notice I'll be working with negative 4 instead of negative 2/3. 1/2, you take 1/2 times 6. 2 goes into 6 3 times. That's going to become positive 3. And then negative 3 times 6 is negative 18. So we got larger numbers, but we don't have fractions. Don't have to do this, but it's a nice side thing that we can do. Down here, oh, come on. Oh, that's good. We're going to take 4 times row 2 and then replace it. So 4 times 1/4 is 1. 4 times negative 1 is negative 4. And 4 times 11/4 is going to be 11. So far, so good? Okay. Now remember, I want to get negative ones here, or I want to get ones along this diagonal. I want to get zeros everywhere else. So this is where we get to be a little creative. There is not one way to approach this, but typically if you'll start here and you try to get zeros, again, if this was larger, you would try to get zeros all in this row, except for this first one. Then you'll turn this into 1 at some point. Then we'd want to get zeros above and below this one, right? Because the goal is again, maybe I'll put it down here. What we're shooting to get in the very end is 1 0 something, 0 1 something. And these underlines, that's our solution. That's our solution for x is the first one. Our solution for y is the second. That's what we're trying to get. And again, this is part of the reason I like this, because it's sort of a problem solving, and we could do things differently and still come to the same answer. So what I'm going to do is I want to get rid of this 1. So if I multiply this by positive 4, right? If I turn this to a positive 4, and then I add row 1, which has a negative 4, positive 4 plus negative 4 is going to be 0, right? So the way I note that is I'm going to take row 2, and again, I've already multiplied it by something, but I'm going to take row 2. What does I say? I'm going to multiply it by a positive 4. And then I'm going to subtract row 1. And then I'm going to put that back where row 2 is, right? So I kind of take it out, like say, take it out to the shop, do the work on that line, and then I replace the line with the new one. So that's going to be whatever this new thing is going to just replace row 2. So row 2 times 4, right? So that's going to give me 4, negative 16. 11 times 4 is 44. I'm going to, actually not, I'm not going to subtract, sorry, because it's already negative. I'm going to add row 1. So row 1 up here is negative 4. Negative 4 plus 3 minus 18. So 4 minus 4, let's see. So I rewrite row 1, which I didn't really do anything to. I mean, I didn't want to change it yet. 4 minus 4 is 0. Negative 16 plus 3 is negative 13. And then 44 minus 18 is going to be, that's 3426. Thank you. Okay. So we can see I'm getting along the route. These numbers are getting big, so could I divide both of these by 13? As 13 goes into 13, 13 goes into 26 two times. So we kind of it's looking at patterns and saying, how can I make these numbers easier to work with? So I'm going to, but you see how you need a lot of room, and I'm already running out of room. I'm going to take row 2, and I'm going to divide it by 13. So now I'm at -4, 3, -18, because I didn't do anything with it. Let me erase this thing. This is getting in the way, but it's what we want to have. And so I divide everything by 13. So 0 divided by 13 is still 0. I'll leave it at that. So -13 divided by 13 is -1. And 26 divided by 13 is 2. And now what I want to do is I want to get rid of this 3. So remember, I've got my 0 here. I want to get this to become 0. So I multiply this by +3, right? This row 2, and then add it here, and then I'm going to replace it here. Okay, so let me see if I have enough room here. So I'm going to take 3 times row 2, and then I'm going to add that to row 1, and I'm going to put it into row 1. I'm not going to actually change row 2. I'm going to leave row 2 just as it is, but I'm working with it and then adding it here. Okay, so 2 times row 2 gives me, see if I can do it up here, or 3 times row 2, I get 0. That's why it's nice to get the zeros, because they stay 0. -1 times 3 is -3, and 2 times 3 is 6. I'm going to add that to row 1, which is -4, +3, and -18. Oops. And then I add those together. So my new matrix, row 1 becomes -4, +3 and -3 becomes 0. And then what did I have? I have 6 and -18. That's going to be -12. This becomes 0, -1, 2. And we're almost there. It seems like, wow, when are we ever going to get there, right? We've got a -1 here, so how can I get that to be +1? Divide or multiply everything by -1. Let's see. Just one more step, and we'll do it up here. So I'm going to take row 2 and multiply it by -1. So I get 0, +1, -2. I'm going to take row 1, and that's a -4, right? I want that to be a +1. So how do I turn -4 into +1? I take row 1 and multiply by -1/4, or divide by -4. -4 divided by -4 is +1. 0 divided by -4 is still 0. And -12 divided by -4, +3. And again, this is just an example to kind of show you how to do it by hand. We're going to get you using your graphing calculator. We have our solution, right? X equals 3, y equals -2. Hopefully I got it right. Again, I was just doing this live, so possibly I made some mistakes here. I think I'm good. Any questions on what we did here? And again, why did I do each one? It was just kind of like, it's a puzzle piece. I know what I'm shooting for is to get these 1s and these 0s. And I just found, and sometimes you do the wrong thing, and but if you get things to all be 0s first, those are great, because mathematically, whenever you multiply 0 times anything, it stays 0. It's one of the few numbers that will do that. In fact, I think it's the only number that's, multiply by 1, it gets changed. So, and then at the very end, you turn whatever those diagonals are, you just divide by whatever they are. That'll turn them into 1. Oh, if you want to watch the video, they kind of go through that. I guess I was supposed to do it here. I gave myself more room. But the good news is we got the answer 3 and -2. 3 and -2. That's what we got, right? 3 and -2. Good. Okay. What I'm going to do with this one, again, I could show you that the calculator will do, but we're going to do it with one that's a little more complicated. So I'm going to go through the steps of using the calculator to do this. It's a 3 by 4 matrix, right? So I think we would set up the matrix, right? Just the coefficients. So 1, -1, 5, -6. You could, and again, check that you've got these. To solve this system, we're going to go to our calculator. And this is is it open? Here's coming. Okay. It's good that we kind of have the space on Friday because I can maybe do this. This should hopefully get you enough, and then we can maybe start class on Wednesday with a few more examples in this, and then get into the next set. Let's see, which one is this? I think this one is that account. Okay, here we go. Okay, just a reminder, I'm going to clear out my matrices. So go to memory, memory management, matrix, and I only have 2 matrices, but I'm just going to go delete, delete, just so, you know, again, part of this is you really got to keep track of which matrices you've got and what you're working for. So first thing we have to do is enter that matrix. So I go to matrix, I have to go over to edit, and since it's all clear out, I'm just going to put it in matrix A. And let's see, where is my, here we go. Let's keep these things for now. And then see if we can do this. So I have a 3 by 4 matrix, right? So I have to say it's a 3, enter, by 4. Gives me the setup. There we go. We enter the matrix in, and I can do 1, enter, -1, enter, 5, enter, -6. Be careful, because if you enter it wrong, and again, that's why I sometimes get going too fast and it gets behind or something, but this is crucial. If any programmers in here, you've ever hear of garbage in, garbage out? If if your syntax is wrong, you've got garbage that you're putting in, you get garbage back out. So you can't get a correct answer if you don't put in the correct problem, I guess, is the basis. And then 1, but oops, not negative. Let's see. 3, 2, 5. Okay, so once we have it in there, major first step. Second thing we do is we get back to the main screen of the calculator. So I go second, quit. Notice I'm just at the calculation screen. I'll clear this out just to kind of make it clear. What I need to do is I need to go back to matrix. I need to tell it to give me the magic formula and then apply it. So the magic formula is I go second, math. No, I go second, matrix. There we go. This is where I'm going to start using my middle tools, my math tools. Now you could there's actually in here, you could do it row by row if you wanted to, but that's a lot of work. So who wants to do that? Why not do the magic thing, which is called RREF, reduced row echelon form. And that's basically what the last part of the lesson is saying, is that this is what we've been doing, is it's called reduced row echelon form. I don't know why, it's just kind of cool names. Echelon was probably somebody's name, I don't know. But we're going to reduce the rows down to the answer key. So reduced row echelon form. The one above it, REF, is close, but it's not exactly right. So we want RREF. So we hit enter, and notice that's what we get. What we now need to do is put which matrix do we want to do this to. So then we have to go back to matrix, and this time we have to go over, no, we don't go to edit, we go to names. This is how we use a matrix. Fortunately, we only have one matrix here, but whichever matrix we want, we hit enter. Notice it's put that into the function for reduced row echelon form. We close the parentheses. I'm going to tell you one more thing, is one more step that I found to be helpful. If our answers end up being fractions, if we just put enter now, it will put them as decimals. But if we go to the math key, and notice this first thing is fractions, if we hit that, it will do the matrix, it will do the solution, and if there are any decimals or fractions, it will give it to us as a fraction, which is nice because that's what WebAssign usually likes, right? So I'm not sure if this one is or not. Oh, this one's all integer values, so we're okay. But had they been fractions, you want to have that key, otherwise you get these decimals. Okay, this is our solution, and it has a solution, right? X is 1, Y is 2, Z is -1. Wasn't that much nicer to do than the last one? And it was bigger, wasn't it? It was a 3. We would have been here till probably lunchtime doing that one, because I would have made some mistakes along the, but this will give it to us. Okay, so there is a solution, and we're good. What time? Oh, we're out of time. Sorry, I don't want to keep you too long. Use this method. Now, you won't be able to get too far into the homework. What we'll do is start class. We're going to look at basically the rest is to look at a few examples. What does it look like when there is no solution? I don't want to rush into that. What does it look like when there's an infinite number of solutions? I don't want to rush into that. So that's what we'll start Wednesday on. But this, practice with them a little bit, because this is tedious, but it's a lot better than having to work through them all the way through. Okay. But I wanted to do it one time so you know what's going on. The calculator is basically doing the same thing we did. It's just faster. All of them, yes. Any matrix operations to get, yes. If we ask them on the test, it'll be like can I multiply by this? So know what's going on, but we're not going to give you to say, okay, show me all your handwork. No,